Good morning. Hello, class. This is my muscular physiology video assignment by Adonis Perez. Okay, we're going to start off by introducing exercise metabolism and the lactate threshold. What is exercise metabolism? Exercise metabolism is how your body burns fat, sugars, and proteins to create energy for movement during physical activity. The lactate threshold is the point during exercise when your body produces lactate faster than it gets rid of it, which makes you feel tired. The harder you push yourself, the more oxygen your muscles need, and the lactate threshold marks how intense your workout can be before fatigue kicks in. Name the three following factors to explain the lactate threshold. 1. The reduced rate of lactate removal from the blood. 2. The recruitment of fast-twitch muscle fibers. And 3. The increased glycolysis rate caused by adrenaline, also known as your friend. 4. What are the practical uses of the lactate threshold? 1. The prediction of the endurance performance. By identifying an athlete's lactate threshold, you can predict how well they perform in endurance events such as the 10K run, marathon, or cycling race. For example, a runner who has a higher lactate threshold can sustain a faster pace before fatigue sets in, which often translates to a better performance. 2. The training guidance. Understanding lactate threshold helps athletes tailor their training programs. Athletes can train just below their lactate threshold to increase their ability to tolerate higher intensity activities without fatigue quickly kicking in. This is especially useful for events like triathlon or long distance cycling races. For example, this is a visual representation of athletes in a triathlon, and they are using their lactate threshold. Why do many prefer not to use the term anaerobic threshold to signify the lactate threshold? One, because it's the wrong impression of what's happening in the body. The term anaerobic threshold suggests that the body has completely shifted to an anaerobic energy production where oxygen is no longer used. However, in actuality, the lactate threshold is still primarily relying on aerobic metabolism. So lactate accumulation occurs because the rate of lactate production exceeds its clearance, not because the body has switched to anaerobic energy systems. Therefore, using the term anaerobic threshold inaccurately applies that the body is no longer using oxygen, which is not the case at this point. 2. It's oversimplification of the process. Anaerobic threshold oversimplifies the complicated process of energy production during exercise. While lactate threshold accumulates as exercise intensity increases, it is not solely due to a shift from anaerobic to aerobic systems. The body still uses aerobic pathways and lactate buildup primarily because the aerobic system can no longer fully meet the energy demands, not because the system switches to anaerobic. For these reasons, the lactate threshold is preferred because it more accurately reflects what's happening in the body as lactate builds up during exercise. The term highlights the connection between lactate accumulation and aerobic energy use without causing confusion by wrongly linking the process to anaerobic metabolism. For example, this is a visual representation of the lactate threshold in a trained individual. Introduction to bioenergetics. Bioenergetics is the study of how the body uses energy to perform different activities like moving, breathing, and growing. I will explain how the body makes ATP both aerobic and anaerobic, and describe the different pathways involved. Muscle cells produce ATP using three metabolic pathways. One, the phosphocreatine PC breakdown. Two, the breakdown of glucose and glycogen, also known as glycolysis. And three, oxidative formation of ATP, also known as the Krebs cycle or the electron transport chain. These pathways can be either aerobic or anaerobic. Most importantly, aerobic pathways require oxygen, and however, anaerobic pathways do not require oxygen. So here's a short summary of the phosphocreatine breakdown. The ATP-PC system is a way the body quickly produces energy for short intensity activities by using stored phosphocreatine to regenerate ATP. When phosphocreatine breaks down, it helps replenish ATP, allowing muscles to power through quick actions like sprinting, high jumps, or lifting heavy weights for just a few seconds. This anaerobic process is key for these high intensity bursts. After these efforts, it takes about 60 to 120 seconds for the aerobic metabolism to replenish about 60 to 90% of the phosphocreatine used. Now I'm going to give a quick overview of glycolysis, the Krebs cycle, and the electron transport chain. Glycolysis is the breakdown of glucose rapidly without oxygen and ATP, resulting in 2 ATP and 2 pyruvic acid. There are 10 steps in glycolysis. NADH is the storing energy as electrons. For example, there's two scenarios. If there's no oxygen available, pyruvate becomes lactate acid or lactate, also known as fast glycolysis because it's less than 60 seconds. However, if there's oxygen available, pyruvate enters the mitochondria and starts the aerobic production of ATP, also known as slow glycolysis, because it can go up to 2 minutes. Now I'm going to quick overview of the citric acid cycle. The citric acid cycle is aerobic ATP results from the cooperation between the citric acid cycle and the electron transport chain. The citric acid cycle completes oxidation of fuels, for example, fats and proteins, to provide electrons for the electron transport chain. The Krebs cycle occurs within the mitochondria, and this cycle can produce 4 ATP molecules directly per molecule of glucose. What is the electron transport chain? The electron transport chain is a crucial process in cellular energy production. It takes the energy released from moving electrons through a series of proteins and uses it to create ATP, the cell's main energy currency. At the end of this chain, the stored energy is harnessed to produce ATP, powering various cellular activities. It occurs in the mitochondria as well. What is the difference from FADH and NADH? These are both carrier electron energy molecules. They transfer hydrogen and associated electrons in the mitochondria for energy production via the aerobic pathway. This is a visual representation of the electron transport chain. There's 3 pumps: the first pump, the second pump, and the third pump. As you can see in the picture, this process uses NADH and FADH to create the electron transport chain, and then becomes ATP synthase, and this is the intermembrane space, and yeah, okay. Let's discuss the scientific study regarding red meat associated with cardiovascular disease. So, if my friend told me about a study linking red meat to mortality or cardiovascular disease, I'll explain that not all studies are created equal, and the strength of their conclusions depends on the type of research and is placed on the pyramid of evidence. The pyramid ranks evidence by reliability, with experts' opinions at the bottom and meta-analysis at the top, the strongest. Studies on dietary habits like red meat consumption and long-term health outcomes are usually observational studies. These involve observing people's behaviors and health over time without intervening. So they show the correlations, but not proving cause and effect relationships. While observational studies are valuable, they are lower on the pyramid of evidence than randomized controlled trials or systematic reviews. That's why it's important to interpret their findings with caution and consider stronger evidence when making decisions. Whenever I see the word associated in a study, it's a clear sign that it's likely going to be an observational study. And this is a visual representation of the pyramid of evidence. And as you can see, observational studies are the weakest. Expert opinions are the weakest evidence, and as they go up, the highest evidence is meta-analysis. The strength of the evidence, the higher the pyramid is, the higher the strength of the evidence. Skeletal muscle. How would I train an athlete based off the force velocity curve? The first force velocity curve shows how force and speed are connected during muscle movements. When one goes up, the other one goes down. For example, you can generate the most force when moving slowly, like lifting a heavy weight. However, you could move the fastest when using little force, like throwing something light. The force velocity curve can help guide how I can train an athlete because with training and both force and speed can improve, but the focus depends on the sport. If the goal is to move faster, like in track and field, the training should emphasize speed. On the other hand, if strength is the priority, the focus should shift to more heavier and slower movements. This ties into the principle of specificity. Training should mimic the demands of the athlete's sport. This is the visual representation of the force velocity relationship. You generate the most force when moving slowly, and you move the fastest when with little force. Respiration and cardiovascular. Does supplement oxygen during game improve game performance? Yes, supplemental oxygen during games can potentially improve performance, especially in high intensity sports or for athletes who are fatigued. Here's why. One, there's increased oxygen delivery. Supplemental oxygen helps increase the amount of oxygen available in the bloodstream. This can enhance endurance and support muscle recovery, especially when oxygen levels are low due to increased physical exertion. Two, faster recovery. Breathing in oxygen-rich air helps the body clear lactic acid more quickly, which reduces muscle soreness and speeds up recovery between intense efforts. And three, improve aerobic capacity. For athletes involved in activities requiring prolonged endurance like soccer or basketball, supplemental oxygen may enhance their aerobic capacity and stamina by ensuring that the muscles are properly oxygenated. However, it's important to note that its benefits are more pronounced during periods of rest or recovery rather than during actual gameplay. While oxygen can support recovery and endurance, it doesn't directly improve performance while the athlete is actively exerting themselves as the body adjusts to oxygen levels during normal training. And this is a visual representation of the different sports, basketball, baseball, football. Okay. What cardiovascular adaptations contribute to the increase in VO2 max with exercise training? What is VO2 max? VO2 max is the maximum amount of oxygen that the body can utilize during exercise. Cardiovascular adjustments that contribute to an increase in VO2 max with exercise training include increased stroke volume. Stroke volume is the amount of blood the heart beats per minute. No, stroke volume is the amount of blood the heart pumps per beat. With regular training, the heart becomes more efficient and the stroke volume increases, meaning more oxygen-rich blood is delivered to the muscles during exercise. Improve cardiac output. Cardiac output is the total volume of blood the heart beats per minute. As the stroke volume increases, the cardiac output improves, allowing for better oxygen delivery throughout the body. And three, improve oxygen utilization. With consistent aerobic training, the muscles become more efficient at extracting oxygen from the blood, which helps also improve the VO2 max. And four, the lowering resting heart rate. Over time, the heart becomes more efficient at pumping blood, and it can pump more blood per beat, meaning that the heart doesn't need to work as hard during rest or low intensity activities. This picture, this is a visual representation of typical resting and maximal exercise values for untrained and trained athletes and in college. So what I wanted to highlight in this table was that, as you can see, in the trained male athlete, they have a higher stroke volume and cardiac output compared to an untrained male athlete. The trained male has a stroke volume of 180 millimeters per beat, and untrained male has 70. That's a major difference. Thank you for watching my presentation, and I hope you enjoyed.